And as it keeps, like the water keeps reducing in volume. Now when it gets in this position, the pump starts pumping water back. And when the pump is pumping water back, it is going to be elevated until it gets to this position, vertical again. So hello, so yes, welcome to another tutorial of automation. And in today's video, we are going to be shining light about controlling water pumping. So upon this, we shall be using a float switch, and I'll give you around like 4 ways of connecting this. We can connect it through a single phase pump or 3-phase pump. We can also use it in overhead controlling and also underground pumping. So for overhead controlling is when we are meaning like water should not overflow when you're pumping to the pump. And then for underground pumping is when water is actually done in your well and you don't have sufficient water, and then you want to let your pump stop dry running. So what does dry run mean? Dry run means is you don't have enough water in the underground tank or maybe in your well, and your pump should not run in that condition, because when your pump runs in that condition, it's going to be overheating and then you will lose your pump. It cannot run a cycle in the dry run method when it is under pumping. So what is in this float switch? This is the schematic of a float switch. A float switch is made of 3 terminals. One terminal is the common and the other terminal is black. Common is black, and then we have the blue, and then we have the brown. So all these wires are going to be coming through here. They are terminated over here. I think you can see we have got 3 wires, and then basing on those wires you can connect your power supply. Either you power the supply of the pump or maybe you cut it off. So in most times, if you want to use it for overhead, you can use 2 wires. That is the common, and then you kill brown. Because when you're in overhead, you want to pump when it is actually like this. You understand? In overhead, yeah, you have to pump when it is in this position, because when it is in this position, that means water in the tank is actually done. But whenever the water is full in the tank because of floating, it will be like this. So that means the switch will be empty. So sometimes people try to control by powering this using the live wire, and some people use the neutral wire. So for me in this diagram, I have used the neutral wire, and also in the simulation how you can perceive it in your brain, I have used the neutral wire to complete or make the circuit. Now what else? And then this is the 3-phase pump. It has a different connection. It is not gonna operate like this other single phase pump. So if we run it, and then this is the circuit breaker, 2-pole circuit breaker, and then the miniature circuit breaker, we bring them on. The pump has to be operating because it is in its normal opposition. So we want the water to be coming. So in the condition whereby the water is finished inside the well or the underground tank, it will shift from here to here. So when it shifts, that means the pump won't be receiving water. Won't be pumping water. And if it goes back in that same condition, it will be pumping. So this is the opposite way of this one. This one we just want to, if I switch them both on, it will. This is for overhead. For overhead, I only want the pump to stop operating when it comes up like this. So that's how it operates as well. And then for the 3-phase pump, it is a little bit so different, because we are not going to switch off via this. It is not going to be working via this this float switch. One of the reasons, because 3-phase pumps can even be drawing more current. And then another thing is, like, you can trip one line, but the other 2 lines will still be operating. Maybe if you have there's something we call 3-phase, the 3-phase power detector. Whenever there's one line missing, it will trip as well. Maybe if you have that, but majorly you have to use a contactor. You buy this contactor and then you energize it using 1 phase. So I was meaning the phase sequencing relay. So when you come and close here and you close here, you see power is over there, but the float switch has to give the command. Let's say it is overhead. Until it goes in the overhead condition is when the pump is going to be running, and if it does not run. So that's how you connect all the three. So apparently we are not going to do it here because in my car operation over here I don't have 3-phase supply. Neither do I have this 3-phase contactor, but these ones are all available. I'm going to do the practical using this, and yeah. And the fifth way of connecting this is maybe if you choose to use a PLC. So if you choose to use a PLC, the power supply of this thingy here, you use a 24 volts DC, so you can get a signal to the PLC. That we shall do in the next video as well. So, okay, let me dive in the connection, and I do this, then I see the outputs. So whenever you have water in your tank, this thing is going to be in this position. Like, it's always going to be in this position. So the moment water is decreasing, it will keep on, like, you know, midway the tank, you'll find it is in this horizontal position. And as it keeps, you know, like the water keeps reducing in volume. Now when it gets in this position, the pump starts pumping water back. And when the pump is pumping water back, it is going to be elevated until it gets to this position, vertical again. So you see, in this kind of operation, we have used only 2 wires. That means I have connected black and blue. So if you want to work on overhead control, if you want to control the overhead tank, you have to be using black and blue. I don't want to be restricting you from black and blue. I just want you to use the method whereby we found the normal closed and normal open using this multimeter. So if you use that, the reason as why I don't want you to use black and blue and brown theory is because one day the manufacturer will end up coming up with other colors, and if they come up with other colors, what are you going to do? So you have to learn the basics behind. That's why I've taught you the one of using the multimeter. So let me do the rewiring, and then we'll find out if you want to do like a dry run protection to protect the pump where you're pumping water from. If the water is finished, how to turn it off and how to turn it on again. So, and again, the other thing is you can use these two if you want to do both. If you want to control underground, and if you want to again control overhead parallelly, so you can also achieve that. It's only a simple logic. You have 2 switches that are connected in series, and then you use AND condition. AND condition is when this is high and this is high, what is my output? So still you can achieve that using any of the methods I'll be using. Okay, so for dry run protection, we want to always run the pump when it is in this mode. This means there is water inside the well or inside any underground pump tank you're using. But when we face this condition, we want the pump to be off, because definitely if it is in this position and this is your pump pumping water, let's say this is your pump pumping, and then it is in this condition, that means there is no water. When there is water, it starts getting elevated up. Until it reaches this condition, and then it runs your pump again. So this is how you can actually protect your underground pump from getting, like, you know, overheated or pumping without water, whereby you're going to be killing it severely. Not, you know, because in dry running condition, in this condition, if it runs within like 5 minutes to 10 minutes, you're going to be losing your pump or something that you're using. Your pump, definitely it will be getting gone. So we shall be meeting in the next videos. If there is anything or any inquiry that you have over there and you want to ask, feel free. I'll be there to reply. Thank you.